regarding this. So it was said that the state diagram is one which is going to represent the relation between the states, the present states and the next states. So one kind of state diagrams are having only the present state and next state conditions, and the another set of state diagram is having the input also, the external input also, along with the present state and the next state conditions. These are the two things which have visited yesterday, and also we have seen a problem also. One particular problem has been discussed yesterday. Right. Now the next thing is, next issue, if we consider yesterday's issues as issue number 1 and issue 2. So issue 1 is the one where the Qn plus 1 is determined by Qn itself, and default is the clock. And issue number 2, so Qn is being determined based upon Qn plus 1 is being determined based upon Qn and also some external input value. Now here also the default condition of the clock signal will be there. So it may be positive edge or it may be negative edge also. It may be either a positive edge or it may be either a negative edge. Right. Now we'll discuss issue number 3. Issue number 3. In the same mod 8 up down counter, I will include external output also. Now external output will be equal to 1. Now whenever I am reaching a state which is divisible by or reaching a state which is having minimum number of ones is equal to 2. Can you draw a state diagram for this? External output is included here is equal to 1 whenever I am reaching a state so which is having minimum number of ones is equal to 2. Minimum number of ones 2 unte chalu output anedi 2 avutadi, right? So here we shall represent it. This is a mod 8 counter where we have a control input. If C is equal to 0, so it is going to be a down count, and if C is equal to 1, now it is an up counter, right? So if I am taking state as 0, if this is my state 0, if C is equal to 1, what will happen? First let us draw the states. Output we shall insert later. Can you hear me? Am I audible for everyone?
Yes, sir.
Right. So whenever C is equal to 1, what will be my next state? If C is equal to 1, so the state will be 0, 0, 1. If C is equal to 0, what will happen?
1 sir.
Right. So it will be 111, which is equal to 7. And if my present state is equal to 1, and again if C is equal to 1, what will be my next state? 0, 1, 0, 2 will be my next state. Present state is 1. If C is equal to 0, what will be my next state?
0 sir.
Right. C is equal to 0. Or else we'll write it clearly. External input is equal to 0. Here input is equal to 1. And here input is equal to 1. And this is input is equal to 0. Right. Now I'm present at a 2 if the state is equal to, sorry, if input is equal to 1, what will happen? I will enter into 011, which is equal to 3. If it is 0, I will be entering into the 1 state if input is equal to 0. Now present state is 3. So if input is equal to 1, I'll be entering into the state of 4. State 4. And if input is equal to 0, this one, input is equal to 0. Present state is 4. And if input is equal to 1, I'll be entering into the 5. And if input is equal to 0, this moves here. So present state is 5. If input is equal to 1, it enters into 6. It enters into 6. And if input is equal to 0, it reaches here. And 6 moves to 7. If input is equal to 1. And 6 get back to 5 if input is equal to 0. And next 7 will move to 0 if input is equal to 1. And 7 will move to 6 if input is equal to 0. Up to this particular point, is it clear? Is it clear? Up to this particular part, right? And next we have inserted one more condition here, that is external output is equal to 1. And when it is 1 and when it is 0. So it is equal to 1 whenever I am reaching a state. I am reaching a state, that is whenever I am reaching a state in the sense the next state value. Next state which is having minimum number of ones is equal to 2. See here, how many ones are present here? How many ones are present here?
2 sir.
2. So whenever I am entering here, what should be my output? What should be my output value? Right, 1. Next condition, see this. How many ones? So here also we have 2 ones. Now here also output must be 1. And here also we have 2 ones. So output must be equal to 1 minimum. So maximum it can be 3. So here also, see this. So here also my output is equal to 1. Is it clear? So whenever the minimum number of ones is equal to 2, output must be 1. Now what about the output in the remaining cases? What about output in the remaining cases? Remaining cases should be zeros. Why? Because so whenever we are representing input, see input lo em chesam manam. So if here it is input is equal to 1. ఇక్కడ input 0 అని మెన్షన్ చేసాం. ఓన్లీ ఇన్పుట్ 1 ఒకటే మెన్షన్ చేసి దీన్ని మనం వదిలేయలేదు కదా, ఇలా డ్రా చేయట్లేదు. So input other input value is also mentioned. Input 0 mention chestam, input 1 mention chestam. Similarly, so when you are saying that output is equal to 1 for certain cases, so you need to define here also. Now here output is equal to 0. In this case, output is equal to 0, and here also output is equal to 0, and here this is output is equal to 0, and here output is equal to 0. In this case, output is 0, output is 0 here, output is equal to 0. Now here output is 0, output is equal to 1. Here this is output is equal to 1, and here it is output is equal to 0, and here output is equal to 0 again. So here output is 0, and this is output is equal to, now what is the output here, 1 or 0? Whenever we are moving from 0 to 7, what is the output value here? It should be 1. Is it clear for everyone, or any doubts here? If you are having any doubts, you may point out here itself. Can we proceed? Shall we move ahead? Hello? Hello? Can you hear me?
Okay.
Right, okay. So we shall redraw it clearly. So 0, 0, 0. Then this is 0, 0, 1.
సార్
Yes, tell me.
సార్ అక్కడ 110 కి 101 కి వెళ్తున్నప్పుడు అవుట్పుట్ 0 వేసేసి
Repeat it again.
110 నుంచి 101 కి వెళ్తున్నప్పుడు
Right. Perfect. It should on. Output is equal to 1. Right.
సార్ అలాగే 100 నుంచి బ్యాక్ వెళ్తున్నప్పుడు కూడా 1 కదా సార్?
ఎక్కడ 100 నుంచి
011 కి వెళ్ళేటప్పుడు సార్.
Right, there also it is 1.
నెక్స్ట్ స్టేట్
There also it is 1. Zero, 1, 0.
Sir,
Yes, tell me.
111 నుంచి 110 కి వెళ్తున్నప్పుడు కూడా అవుట్పుట్ 1 కదా సార్?
111. Okay, I'll correct it. Here also it is 1. Any other cases? Alanti any cases unnaya? Any other states we have left in that way? Whenever the next state is equal to minimum number of 2 ones unte output 1 avali. Inka edanna case migilipoyinda? Is there any other state which is not addressed? Check it once properly. Is there any other state?
నో సార్, ఇంకా అంతే సార్.
No, I don't. Right. Okay.
నో సార్
0, 1, 1 to 1, 0, 0. 1, 0, 0 to 1, 0, 1. 1, 0, 1 to 1, 1, 0. 1, 1, 0 to 1, 1, 1. And from 1, 1, 1 to 0, 0, 0. So this is happening whenever the input is equal to, what should be the input here? Input 0 no
1,
1.
sir.
So input is 1. What is output here? Whenever it is 0 0 0 to 0 0 1, what is the output?
0,
0,
sir.
So it is represented in this way. This is the standard format. So the numerator, denominator, so numerator is going to represent my input condition and denominator is representing my output value, right? This is also 1 0. And what about this case? 0 1 0 2 0 1 1. 0 1 0. Right, it is 1 1. Input is 1, output is 1. And this is again 1 by 0. This is 1 by 1. And this is 1 by 1. This is 1 out 1 by 1. This is 1 by 0. Right, one particular condition has been drawn here. We'll draw the another condition also. This is another condition. When does this happens? For what condition? 0 moves to 7. What should be input value?
0, sir.
What about output value should be 1. Right. Similarly, this is another one where it is again 0 by 1. This is again 0 by 1. What about this condition?
0 by 0.
0 by 0, perfect. And what about this?
0 by 1.
0 by 1. What about this?
0 by 0.
0 by 0. What about this? 0 by 0.
0 by
What about this?
0 by 0.
0 by 0. Right. So this is a state diagram in which we have. So if we draw a state transition table for this is a state diagram. This is a state diagram. Now in some textbooks, now what they will be doing is they will be representing, so 0 0, this may be represented with S0, this may be represented with S1, this with S2, so S3, so S4, so on, and they will be saying that S0 is for 0 0 0 and S1 is for 0 0 1, S2 is for 0 1 0 and so on. S7 is for 111. అలాగూ రిప్రజెంట్ చేస్తారు, and we have directly represented the conditions here. Now the state transition table, how to draw state transition table for this? State transition table. In state transition table, so the first is the present state. Now how many bits are required to represent present state? 2 bits or 1 bit or 3 bit? 3 bits are required. Let it be Q2, Q1, Q0. Now what about external input? How many bits it is? External input. Only one, right? Let it be some X or C or Y or something else. Now the next states are represented with how many bits? Or you can represent Y here first. ఏదైనా represent చేయొచ్చు. Output. What about output? How many bits it is? Output any bits ఉంది? Only 1 bit Y. Next state will be represented with how many bits?
3 bits, sir.
So Q2 plus, Q1 plus and Q0 plus. Is it clear how we have concluded this or arrived this variables? Variables allow అర్థమైందా? We have present states, we have the input value X, output value Y, and the next state conditions which are Q2 plus, Q1 plus and Q0 plus. Now how many flip-flops are required for this? How many flip-flops are required for designing of this particular state machine? 3. So if it is a D flip-flop, simply it will be D2, D1, D0. Right now it is if my present state is 0, 0, 0, and if x is equal to 0, now what is the output and what is the next state? My present state is 0, 0, 0. Present state is 0,
Output
0,
1 1,
0.
next state 1 1 1.
X is equal to 0. X is equal to 0. Output is next state is triple 1. Output is 1. Output is 1. Now if it is 0, 0, 0, and if x is equal to 1, now what will be my next state? 0, 0, 0, and if x is equal to 1, what will be my next state?
0, 0,
0, 0, 1. What about output?
0, 0.
0, 0, 1, and output is equal to 0. Now if the state is 0, 0, 1 and x is equal to 0, now what will be the next state? 0, 0, 1, x is equal to 0. 0, 0, 1, triple 0. 0, 0, 0. Output is 0. And 0, 0, 1, if x is equal to 1, what will be the next state?
1 0.
Right, 0, 1, 0, and output is equal to 0 here also. Right, you please fill this table quickly on your notebooks and tell me the expressions for D2, D1, D0. So 0, 1, 0 with the 0 and with 1. 0, 1, 0 with 1. Next 0, 1, 1 with 0. 0, 1, 1 with 1. One double 0 with 0. 1, 0, 0 with 1. 1, 0, 1 with 0. One, 1, 0 with 0. 1, 1, 0 with 1. Triple 1 with 0. And triple 1 with 1. You will be getting 16 conditions. 16 conditions. What will be the state here? 0, 1, 0 with a 0. And 0. 0, 1, 1 with 1. 0, 1, 0 with 0. 1, 0, 0 with 0. 0, 1, 1 with 1. 1, 0, 1 with 1. 4. 1, 1, 0 with 1. 1. from characteristic table or excitation table of a D flip-flop. So we know that Dn is equal to Qn plus 1. Dn is equal to Qn plus 1. Now tell me now how you will get the expression for D2 will be a function of what are the variables that define D2?
Q2, Q1.
Right, Q2, Q1, Q0, X. Now, what are the minterms which are present here in D2? Sigma m of
0,
0. Next,
7,
7. Next,
9,
9,
10,
10,
11,
11,
12, 13, 14.
12, 13, 14, 15
Okay.
and the okay, right.
15.
Right, we don't have 15. So similarly, we will be getting the minterms for D1 also in terms of Q2, Q1, Q0, X, and also D0, Q2, Q1, Q0, X. And here we have output also, which is Y. Now, Y will be a function of which variables? Y will be a function of
4 variables, Q3.
right.
Q2,
Y also will depend upon Q2, Q1, Q0, and X. Then after that, you are supposed to design this circuit with the help of how many flip-flops are required here? 3 flip-flops are required. So the 3 flip-flops will be written in this way, drawn in this way. And if this is a D2, this will be my Q2 and this will be my Q2 bar. D1, Q1 and Q1 bar. D0, and this is Q0 and Q0 bar. And this will be provided with a common clock signal because these are synchronous counters. Then connecting the expressions. So D2 you got some expression, D1 you got some expression, and D0 you got some expression. And this is Q2, Q1, Q0. And you will be getting the circuit for Y all. What is the expression for D2? What is the expression for D2? Did anyone completed it? Did anyone has done it? Hello. Right, so you may do it later. Right now in this problem, in this issue, state, next state, which is nothing but Qn plus 1, is depending upon what factors? Qn plus 1 is depending upon what factors?
present state and next Qn and input.
Qn and also input value, which is nothing but X. So present state as well as input, present input. Present input. We have another output which is nothing but Y, which is called as a present output. Now present output is depending upon what factors? It also
Present
depends upon Q and no only present input కాదు, అది కూడా present state మీద depend అవుతుంది, and it depends upon present input also. If you get expression for this, you will understand what is happening. Then expressions మీరు రాస్తే d2 d1 d0 and y కి, then you will be understanding ఎలా రిలేట్ అయ్యాయో తెలుస్తుంది. Use K-maps and get the expressions, then you will be understanding the things more clearly. Right, so this is what it is happening here. So these are the three kinds of state machines. So these are the three kinds of state machines. The first state machine, so state machine 1, 2 and 3. In state machine 1 we have only the next state and the present state, only these two are present. In the second kind of problem, we have qn plus 1, we have qn, and we have present input also. In the third kind of state diagrams, we are having qn plus 1, we have qn, we have present input, and we have present output also. And these are the kind of the state machines which are used in practical purposes. ఇవి యూజ్ చేస్తారు. These are the ones which are used, which will have qn plus 1, which will have qn, which will have present input, and which will have present output. Is it clear? This is next state, this is present state. Is it clear?
Yes, sir.
And these two are only for understanding purpose. These two are for understanding purpose. These two are for academic purpose. And this is for real-time purpose. This is for real-time purpose. In most of the cases, majority of the cases. అంటే అసలు లేకుండా ఉంటుందా అంటే స్టేట్ మెషిన్ 1 ఎక్కడ రాదా సార్ అంటే మేబీ రావచ్చు. But in most of the cases, in majority of the cases, only the state machine 3. So this kind of state machine 3, this kind of examples are used. And ilanti classification ekkada undadu. Don't remember it as a classification. What are state machines ante meer inka radam start cheyakandi. State machines are three kinds: state machine 1, state machine 2, state machine 3. In state machine 1, qn plus 1 qn will be present. In state machine 2, qn plus 1 qn and pi. In state machine 3, qn plus 1 qn pi po ivanni untai. Don't remember that and don't do that classification. And no classification. అలాంటి క్లాసిఫికేషన్ ఏం లేదో క్లాసిఫికేషన్ ఏదో నేను చెప్పింది, ఓన్లీ మీకు అర్థం అవ్వాలని చెప్పింది. అండ్ డోంట్ మెమరైజ్ ఆర్ డోంట్ రైట్ ఇట్ ఎనీవేర్. ఈజ్ ఇట్ క్లియర్? ఈజ్ ఇట్ క్లియర్ ఫర్ ఎవ్రీ వన్? Right. So do you have any class at 3 o'clock? The people who are present in the links, link 1, link 2, link 3, do you have any class at 3 o'clock? If you have any class here, you can message me. I'll see here. If it is yes, yes అని మెసేజ్ చేయండి. ఇఫ్ ఇట్ ఈస్ నో, నో అని మెసేజ్ చేయండి. మీకు ఏ తెలియకుంటే వి కాంట్ సే ఎనీథింగ్ అని చెప్పి రాయండి. ఓన్లీ వన్ పర్టికులర్ లింక్ పీపుల్ హాస్ రిటర్న్ ఇట్. 53 స్టూడెంట్స్ ఎక్కడ ఉన్నారో వాళ్ళకి మాత్రం తెలుసు, మిగతా వాళ్ళు తెలియదు. ఐ నాట్ ఆడిబుల్ ఫర్ ద రిమైనింగ్ లింక్స్. వి కాంట్ సే ఎనీథింగ్. అదిలా రాజేశ్వరి, మీ క్లాస్లో ఉందో లేదా మీకే తెలియదా?
సార్ పెడతా అన్నారు సార్ క్లాస్, అది ఎప్పుడు పెడతారు చెప్పలేదు సార్.
అంటే ఇప్పుడైనా చెప్పాలి కదా, అట్లీస్ట్ 10 minutes ముందు చెప్పరా?
డిఎస్టీ తర్వాత అన్నారు సార్, కానీ టైం చెప్పలేదు.
3 o'clock క్లాస్ ఉంటే 2:50 కన్నా ఇన్ఫర్మేషన్ రావాలి కదా. Right, so there are the two links Right, Durga Vasu is saying P4 slot empty. So all 3 links. Right, we shall continue with the 5 minutes break. I'll start at 3:05 again. I'll start at 3:05. Draw a state diagram. Write the following. Input output relation table. Now before this, please answer this question. Now from this understanding, what is the information that will be present in state diagram? State diagram lo emuntundi information?
స్టేట్స్ ఇన్పుట్స్
కంట్రోల్ ఇన్పుట్స్ ఉంటాయి సార్.
Present states, next states, and next inputs, and next
అవుట్పుట్స్
right outputs. Now this is the definition of the state diagram. The state diagram is the one which gives us the relation between present state inputs, present state, next state, inputs and outputs. That's it. అంతే, ఇంకేం గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. No one will be asking you what is the defined state diagram. But for your understanding, the state diagram is nothing but a diagram which will be showing us the relation between present state, next state, input and outputs of a system. That is what a state diagram is. Right. So the table is given here. Present state, inputs, the next state, and outputs. Present state represented with the Qn. Inputs, we have 2 inputs here, A and B. A and B. Next state is represented with the Qn plus 1. Output is represented with Y. Is this clear regarding the variable names? Is this terminology clear? Present state is being represented with the Qn. Inputs are being represented with AB. Next state is being represented with the Qn plus 1. Output is represented with Y. Is this clear?
సార్
Right. 0 0 0 0 1 1 0 1 1. Now first, I want every one of you to draw a state diagram for this. Draw a state diagram for this. 3 9. You may take 3 minutes. 3:12. Draw a state diagram which represents this input-output relation, where we have present state, we have next state, we have inputs, we have outputs, everything. Is it done? If you have completed, please post a message. If you have done, please post a message saying yes. Three 12. Yes. Sheikh Munira Begum, L. Sri Lakshmi, G. Sri Lakshmi, Nagadurga Bhavani, Venkatesh, N.K. Gautam, Swati, Varalakshmi, Durga Prasad, Tulasi, Amani, Dhanalakshmi. What about the rest of the people? Are you doing or not? Right, okay. See this. I too will draw it. You please verify your answer. Now, how many states are present here? How many states are present here? Any states tonight?
2 states.
It's 2 states. See, you are supposed to check only Qn. Don't compare Qn plus 1 to find out the number of states. కొంతమంది ఏం చేస్తారంటే సో దీన్ని ఒక స్టేట్గా తీసుకుంటారు ఎస్ నాట్ అని చెప్పేసి దీన్ని ఇంకో స్టేట్ అని చెప్పేసి అనుకుంటారు సో S1 అని చెప్పేసి డోంట్ మేక్ సచ్ don't get into such issues, don't get confused with those things. So states, and the reason is how they will analyze is present state ఎలా ఉంటుంది దీని తర్వాత నెక్స్ట్ స్టేట్ ఉంటుంది సో అందుకని ఇది S0 అండ్ ఇది S1 కాబట్టి నేను ఇది S0 అని పెట్టుకుంటాను ఇది S1 అని పెడతాను అంటారు. Now it is a wrong way of approach. You shouldn't think in that way. You are supposed to check only this particular column. A column matrame check cheyandi. Right here we have how many different combinations? We have only 2 different combinations. One combination is 0 and the other combination is 1. 0 ఒకటి 1 ఒకటి. Only 2 states మాత్రమే ఉన్నాయి. Only 2 states. We have only 2 states. Now suppose if I represent a 0 with some G and I represent a 1 with some H, let me redraw this particular table. Let me redraw this table here with the Qn, A, B, Qn plus 1 and Y. If G is my initial state and if 0, 0 is my input, what is the next state? What is the next state?
G sir.
G. Y ఏంటి Y ని మళ్ళీ మీరు G అని రాయకండి. Y is an output. Y is an output. A few people will be doing that, so ఇది కూడా G అని చెప్పేసి రాస్తారు. అలా రాయకండి. So Y is output. Y is output. Y is not a state. This is 0 only. Now if this is G and if the input is 0, 1, the next state is again G with 1 and G with 1, 0. This is again G with 1 and this is the G with 1, 1. What is the next state is H with 0. And if H is my present state, 0, 0 is my input. My next state is G with output as 1 and H with 0, 1. My next state is also H with output 0. H with 1, 0. Next state is H with 0. H with 1, 1. Next state is H with 0. Is this clear? Is this clear for everyone? Right. Now we have 2 states here. One state is G is one state. Now H is another state. Right. At present state, if present state is G, And if 0, 0 is my input, what will be the next state? Next state is also the G 0, 0 by 0. And if G is my present state, right, this is done. If my G is my present state, if 0, 1 is input, the next state is also G with output as 1. Then for the third condition, if it is 1, 0, then also it is 1. For the fourth condition, it is moving on to the another state. It is moving on to the another state. Now it is 1, 1 by, what is the value here? Output NT?
0.
Right, 1, 1 by 0. Now if H is my present state and if 0, 0 is the input, what is the next state?
G set.
Right, 0, 0. Output is 1. Then for the remaining cases, this is 0, 1 by 0 and this is 1, 0 by 0 and it is 1, 1 by 0. Is it fine? Does it look simple? That's it. Inte inka. State diagram dinkante inte. Nothing else. Nothing more than this. Nothing more than this. Nothing more than this. Right. The next thing is state transition table. State table or state transition table. Quickly draw state transition table for this. The present state is Q1. Q1 or Q1, how many bits are required to represent the state?
1 bit, sir.
Only 1 bit is sufficient here. Let it be Q. The inputs, how many inputs we have? Present inputs are 2. A, B and bit num. Next state is represented with Q plus. Output is being represented with Y. Then how many flip-flops are required? Flip-flop inputs.
1.
Only one flip-flop, right? Let it be D. Right here, D is a function of Q comma A comma B. This is equal to sigma M of what are the minterms that are present in this?
5, 6, 7, 7.
Right, 3, 5, 6 and 7. 3, 5, 6, 7, which is equal to, if you simplify this, you will be getting expression in this way. AB plus Q into A XOR B. Right, Y, which is a function of Q comma A comma B, this is equal to sigma M of 1, 2, 4 and 7. This is equal to Q XOR with A XOR with B. Right. Do you remember anything of this sort, of this kind?
Full order.
Full order.
It's
This is a full adder, right? Now connect this with a flip-flop. Flip-flop to network connect చేయండి. What is the D value? What we have obtained here? QAB. D ఏం వచ్చింది? AB plus Q into A XOR B. And what about Y? What about Y? Q XOR with A XOR B. How many flip-flops are required here? Only one flip-flop is required. We are taking D flip-flop, which will have Q and Q and Q and Q bar. Right. What is the value of D? D is equal to AB plus Q into A XOR B. So, which is AB, sorry. This is AB plus Q into A XOR B. This is Q into A XOR B. Right, D is written. Now, what about Y? What about Y?
Q XOR A XOR B.
Right. This is Q XOR with A XOR with B. So this is Y. Q XOR with A XOR with B. See, this is redrawn as, this circuit is redrawn as now what are the outputs of a full adder?
Sum and carry.
Sum carry, sir.
Right. Sum is equal to Q, sorry. This is A XOR B XOR Cn. And the carry is AB plus Cn into A XOR with B. Now, are this the same? రెండు సేమా కదా?
Yes, sir.
Yes, sir.
Now, full adder internally it will have both the circuits to generate C out as well as sum as well as C out. See, ఇది సార్ C out ఫస్ట్ రాయాలి, సమ్ సెకండ్ రాయాలి కదా అని చెప్పేసి అలాంటి కన్ఫ్యూజన్స్ పెట్టుకోకండి. సో హియర్ ఐ హ్యావ్ రిటర్న్ ద ఎక్స్ప్రెషన్. ఇది ఏఎక్స్ ఆర్ బిఎక్స్ ఆర్ సి అవుతుంది, ఇది ఏబి ప్లస్ సిఎన్ ఇంటూ ఏఎక్స్ ఆర్ బి అవుతుంది. So when we are writing complete expression, so we can write anywhere, so it doesn't matters. Let C out is equal to AB into AB plus C into A X or B. Now, is this clear for everyone? What we have done?
సార్ డి ఫ్లిప్ లో అంటే దానికి క్లాక్ ఉండదా సార్?
Clock ఉంటుంది, clock ఎందుకు ఉండదు? So we will have clock.
అంటే మామూలు దానికి డిఫరెన్స్ ఏంటి సార్?
We'll have clock, we'll have a reset, we'll have a reset, and we'll have clear. All those things will be there. Right. Now the point is how this is different from the regular full adder. దానికి దీనికి డిఫరెన్స్ ఏంటంటే now here what I will keep is I'll place two registers. This is one register and this is another register. This is the clock. This is a parallel in serial out register. Here also I will place a parallel in serial out register. So this is A0, A1, A2, A3. This is B0, B1, B2, B3. And this is a clock. And from here, this is being loaded. This is also parallel in serial out register. And here I'll take a register. And this is my serial in parallel out register. Serial in parallel out register. Serial in parallel out register. Now I'll collect my output final C out here. Final carry. Well, tell me, can't we use this as a multi-bit register? Use చేయలేనా నేను ఇప్పుడు దీన్ని? Can I use this as a multi-bit register?
Multi-bit adder.
Sorry, multi-bit adder గా యూజ్ చేయలేనా నేను? 4-bit adder గా యూజ్ చేయలేనా?
Yes sir, అంటే క్లాక్ యూజ్ చేస్తే
నా క్లాక్ మొత్తం కూడా నేను సింక్రనైజ్ చేస్తా. క్లాక్ మొత్తం కూడా నేను సింక్రనైజ్ చేస్తా. ఏది మన డి ఫ్లిప్ ఫ్లాప్ కి సీరియల్ ఇన్ ప్యారల్ అవుట్ రిజిస్టర్, ప్యారల్ ఇన్ సీరియల్ అవుట్ రిజిస్టర్. ఐ విల్ బి సింక్రనైజింగ్ అన్ని క్లాక్స్ ని కూడా ప్రాపర్ గా సింక్రనైజ్ చేసుకొని సెట్ చేసుకుంటా. అండ్ డిలేస్ అవన్నీ కూడా నేను అరేంజ్ చేసుకుంటా. Assuming that all the timing constraints are taken into consideration properly, now can I use this as an adder? A 4-bit adder ga use cheyocha?
yes sir.
Use cheyochu kada? So first what will happen here? So first is whenever the clock is given during the first clock cycle, A0 B0 will be sent here. A0 B0 will be sent here. What happens? So here is 0, here it is C0. So this C0 will be again appearing here. C0 వచ్చేస్తుంది ఇక్కడ. Now during the second clock cycle, what happens? So here this will be replaced with A1 and B1, and here what will we have? Here we have C0 here. So A1 plus B1 plus C1. So this gives rise to S1 now, and here this will be C1 వచ్చేస్తుంది. So here, so it will be stored. So first is we will be getting here serial in parallel out. Serial గా in అవుతుంది, parallel గా out అయిపోతుంది. Serial in parallel out. So we'll be getting S0 here, next S1 here, next S2 here, next S3 here. In this way. So this is C0 first, next here this will be C1. Next A1 B2 ఏమవుతుంది, A2 B2 అవుతుంది, and in such case S2 will be generated here, and this will be equal to C2, and this will be the same C2 here, and after that this is A3 and this is B3, and here we will be getting S3 వచ్చేస్తుంది, ఇక్కడ C3 వస్తుంది, which is nothing but the final carry. We can collect here itself. ఇక్కడే final carry ఇంకా కలెక్ట్ చేసుకోవచ్చు after 4th clock cycle. Tell me, can we use this as a serial adder or not? Multi-bit adder ga use cheyocha?
Yes sir.
Right, this is going to work as a multi-bit adder, but can we give all the inputs at the same time? Can we provide, or does this circuit processes all inputs at a time? అన్ని ఇన్పుట్స్ ను ఓకే ఉందా?
No sir.
No sir.
No, it won't process all the inputs at a time. So only per clock only one bit of A and B, bit by bit, A0 B0, next A1 B1, next A2 B2, next A3 B3, A4 B4, AN BN, and hence this is called as a serial adder. This is called as a serial adder. Now area, delay, power. Comment on the area with respect to ripple carry adder and carry look ahead adder. With respect to area and the area will be less. What about delay?
ఎక్కువ సార్.
Delay bit పెరిగే కొద్ది పెరిగే.
Right, delay will be more. Why? Because synchronous operation will not take place here. Simultaneous action will not take place here. Bit by bit operation మాత్రమే అవుతుంది. What about power consumption?
Less sir.
Will be less, right? Less kada. ఏరియా ఎంత ఉంది,
అంటే మరి
డివైజెస్ ఎంత ఉన్నాయి, అక్కడ ఏరియా ఎంత ఉంటుంది.
రిజిస్టర్స్ పెరుగుతాయి కదా సార్.
ఈవెన్ దెన్ సపోజ్ యూ దాంతో కంపేర్ చేయి ఒక 64-bit క్యారీ లుకేట్ యాడర్ తోటి.
అక్కడ కూడా రిజిస్టర్స్ కావాలి కదా సార్ ఆ ఇన్పుట్లు ఇవ్వాలంటే దానికి.
రైట్, ఇన్పుట్లు ఇవ్వాలంటే కావాలి, బట్ ఇంటర్మీడియట్ హార్డ్వేర్ ని చూసుకున్నా కానీ సో క్యారీ లుకేట్ యాడర్, రిపుల్ క్యారీ యాడర్ హార్డ్వేర్ ఎక్కువ ఉంటుంది. మనం రిజిస్టర్స్ ని టైం బీయింగ్ పక్కన పెట్టేస్తే దాంట్లో రిజిస్టర్స్ కావాలి, దీంట్లో రిజిస్టర్స్ కావాలి అని చెప్పేసి, సో ద హార్డ్వేర్ విచ్ ఇస్ ప్రెసెంట్ ఇన్ దిస్ ఈజ్ ఓన్లీ ఫుల్ యాడర్ బ్లాక్. దాంట్లో మల్టిపుల్ ఫుల్ యాడర్ బ్లాక్స్ ఉంటాయి. సో సింపుల్ సీరియల్ యాడర్, వాట్ ఇస్ దిస్? This is nothing but the state diagram of a serial adder. Serial adder state diagram है. This is a serial adder state diagram. What about this? What is this? This is nothing but Cin value. What is this? This is nothing but the Cout value. What is this? This is nothing but the sum value. Right, in this way we can draw state diagram for anything. Right, now a small assignment for tomorrow's class. I'll stop this session here and I want you to draw state diagrams for JK flip-flop, D flip-flop and also T flip-flop. Draw state diagrams for JK flip-flop, D flip-flop and T flip-flop. Assume that y is equal to Qn plus 1 for these flip-flops. Do we have any output y untunda JK flip-flop lo, D flip-flop, T flip-flop lo?
No, sir.
ఏం ఉండదు కదా. Right, if it is JK flip-flop, what do we have? JK ఉంటాయి, ఇంకేముంటుంది, Qn ఉంటుంది, then it is Qn plus 1. Zero, 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 001, 010, 011, 100, 101, 110 and 111. Now tell me, whenever it is 00, what is the value of Qn plus 1?
0, sir.
Assume that we have required a clock cycle here. మనకు పాజిటివ్ ఎడ్జ్ JK flip flop అయితే పాజిటివ్ ఎడ్జ్ క్లాక్ ఉంది అనుకోండి. Now what is the value here?
0.
0. This is equal to 1. Whenever it is 01, what will be the output? 0.
0.
This is also, this is
Sir, 0.
0. For 1 0, 1. This is 1. This is 1 and this is 0. Now what I have said you is assume that there is an output for this. Y అనేది ఒక అవుట్పుట్ ఉంది అని అజ్యూమ్ చేసుకోండి, ప్రాక్టికల్ గేమ్ ఉండదు. అండ్ such y is equal to Qn plus 1. Right, this is 0, this is 1, this is 0, this is 0, this is 1, 1, 1 and 0. And for this I want you to draw a state diagram. Draw a state diagram for this. State diagram draw చేయండి అంటున్నాం. Similarly for the D flip-flop. So D flip-flop ఏముంటుంది? So you will have a D, you will have a Qn, you will have Qn plus 1 and now consider some output as Y. Y కూడా ఉంది అనుకోండి. And for T flip-flop, T, Qn plus 1 and some Y value. Right, I want you to draw these things before you come for the next class. Is it clear? I'll share this PDF. This PDF will be shared. Yesterday, as there is no much information, I haven't shared this PDF. But this PDF will be shared. Thank you.
Sir?
Yes, tell me.
అక్కడే ఏ బుక్ లో చదవాలి సార్? అంటే టోసీలో లేదు సార్ ఇది.
టాస్లో లేదు అంటే ఈమె టాసీలో ఉంటుంది, ఎందుకు ఉండదు?
అంటే జస్ట్ సార్ ప్లీజ్.
Fundamentals of digital design using Verilog HDL. Author Stephen Brown. You may go through this. There you have good examples also, and that you will find the serial adder also. You will find a serial adder example also in Stephen Brown. Fundamentals of digital. See, digital logic, digital design రెండు ఉన్నాయి books. ఒకటి Verilog HDL ఉంది. The same author has written this also. Fundamentals of digital design using VHDL. ఈ బుక్ చదివి నన్ను డౌట్స్ అడగండి Verilog మీద. సార్ మేము చూసిన Verilog కోడ్ వేరేలాగా ఉంది, మీరు చెప్పే Verilog కోడ్ వేరేలాగా ఉంది అని చెప్పకండి. So if you are reading from this particular textbook, then it is not a Verilog code, it is a VHDL code for which the syntax is different. అంతేగాని VHDL చదివేసి మీరేంటి సార్ Verilog కోడింగ్ రాంగ్గా చెప్తున్నారని చెప్పేసి అనకండి. VHDL is different, Verilog is different. Both are different. For both syntax is different and all things are different.